Mars. Desolate. Cold. Unable to sustain human life on its surface. Until now. Introducing the first Martian habitat for humans, inspired by biology found on Earth. Built using state-of-the-art 3D printing technology and advanced autonomous robotics. Modular and made from the Martian surface without human hands. Here's the process overview. The landing. The lander scans its surroundings and selects optimum print area. Rover robots deploy for material gathering. The lander seals to the ground and provides a protected pressurized print environment. Mix materials and prepare for print. The print begins. Place airlocks. Continue print. The walking lander robot moves to create the next structure. Repeat process. Materials. Most of the Zopherus habitat will be printed with materials found from the Martian surface. Martian concrete, made from ice, calcium oxide, and Martian aggregate, are collected by rovers to be fed into the lander for mixing. Precision components, manufactured on Earth, are stored inside the print chamber for transport to Mars. These parts will be placed into the active print as needed, providing structure, access points, breathtaking views, and lighting to the interior. Method of construction. After the lander has selected the printing location, it will provide a controlled and pressurized environment for the print. Even in temperature extremes, storms, and other environmental variables, the print will continue without interference in its contained environment. Once astronauts arrive, the printer will be available to create additional prints, or can act as a mobile emergency pressure vessel. Using two separate printheads, the printer will create structure pressure chambers without the use of removable support material. The first material, HDPE, will provide environmental enclosure and reinforcing. This material will print 2.5 centimeters ahead of the Martian mix to allow printing of overhangs without removable support material. The Martian concrete provides primary structural strength and radiation absorption. The finished print. The communal shell structure provides a space for activities including exercise, recreation, meal preparation, and social interaction. It also serves as the connecting point for the Mars rover and a walkout airlock with suit airlocks for maximum operational flexibility. The center beams provide extra structural support and stairs to the upper mezzanine. The mezzanine level boasts the largest window in the habitat, providing expansive views of the Martian landscape. In addition, it gives sunlight for a small hydroponic garden for growth of vegetation and production of oxygen. Along the back wall are built-in shelving units, supplying the necessary storage for food and water. The crew quarters contain 4 bedrooms for the residents of the habitat, each providing a secluded area for rest and personal time. Every room has storage under the bed and a viewport. The sanitation room is nearby, equipped with a toilet, sink, and shower. The shell also has a ladder for upper access to storage, adding increased radiation absorption for the crew below. The laboratory is complete with countertops for experiments, storage for tools, equipment, and communication systems. The middle desk has under-counter storage and an integrated hookup for a water supply. The lab also has a second rover hatch for easy unloading of field samples. The Zopherus habitat is easily expandable. The unique hexagonal shape will provide interlocking abilities for future residents and additions. The Zopherus habitat, building a new way forward for space exploration and human habitation.